I'm going to go ahead and write the whole thing. ln is short for natural logarithm. Current price divided by strike price plus time to expiration times interest rate, which is the continuously compounded rate, 1/2 volatility squared, and the whole thing is going to be divided by volatility times square root of I could do it in pieces, but I'm going to take care of that and actually write our own VBA function to calculate these. But for illustrative purposes, I'm not going to worry about that. But you can copy that formula. You guys are all done with the formula? I'm going to hit enter. Doesn't make too much sense. I'm making a mistake. Is that D1? Oh, idiots. And you're gonna understand why I call myself idiot. This function n of x, this is the cumulative distribution function of x for normal distribution, for standard normal. In Excel, this is norm s list x. This means probability that the standard normal is less than or equal to x is n of x. Probability to the left of. That's a cumulative distribution. So I need n of D1 By the way, these don't have any percentage interpretation. That n of D1 actually is the probability that this option will finish it. It's also what we call the delta of the option. So if stock price goes up slightly, let's say by $1, the call option price is going to go up by about 56 cents. It's an approximation, not exact. It's basically the slope of the option pricing graph. So call price current price times N of D1 plus minus e to the negative r times t times the strike price. You can think of that as present value of the strike price times N of D2. If you want the formula. I'm going to save and post this, but if you want to work on it, you can work on it by downloading it. But it's not a bad idea to kind of construct it yourself so that, in a sense, you get your hands used to the exercise. One thing about for normal distribution, N of negative D1 is equal to 1 minus N of D1. And I'll show you the case anyway. For example, as you can see, it's identical one. You can calculate it separately, but you don't have to. Let's do this. That comes out of symmetry. So put price is present value of strike price times N of negative D2 minus current price times N of negative D1. Check my formula again. Now we have a kind of working template. So let's go to my Palantir option that I own. Right now, the bid is 87, ask is 93. In fact, I am that one contract bid at 87. So-called implied volatility. For indicative purposes, Robinhood is, I don't think you guys see the left of it. For indicative purposes, Robinhood says it's 90 cents. Assuming that all the other parameters are correct, that's the value of volatility that gives you a 90-cent price. That's what's called implied volatility. But for now, let's enter this. Expiration date is 2025. It's about 2 years. So let's find out the 2-year interest rates. May not even have it. Okay, let's use the 2-year treasuries.